Let's look over here at the sideboard. Algebra 1 on Fun Sock Friday on the 16th of October. SWBA assumes we'll be able to solve absolute value inequalities, section 3.6. We're doing absolute value inequalities today. So we did absolute value equations last class and then this earlier this morning for our section that we just checked, 3.5. Now we're doing absolute value inequalities. So the inequality, the absolute value of x is less than 5, means that the distance from 0 to x is less than 5 units. Does that make sense? Absolute value is distance to 0. So now if its absolute value is less than 5, it means the distance is something less than 5. So could it be 4? Could it be 4.5? Could it be 0? Could it be 3? Could it be negative 4? It could be negative 4. That'd be less than 5 away. Okay? So for here, for our solution set, we'd end up having negative 5. We'd end up having 5 with open circles. And it could be anywhere between those two, right? It could be anywhere between negative 5 and 5. Our x value could be anywhere between those two, because anywhere between those two is going to be less than 5 units away from 0.
Wait, sure. Why are they open?
Okay, because can it be exactly 5 units away from 0? No. Okay, so great question. We did equations last time, so they were always closed circles. But just because it's absolute value doesn't mean it's automatically a closed circle, okay? We have to look for our symbol every time. In this case, it's a less than symbol. Okay? Questions on that? Okay?
Clear up that the point goes towards the smaller number.
Yes. Yep. Now, the inequality, the absolute value of x is greater than 5, means that the distance from 0 to 5 is more, or from x to 0 is more than 5 units. I said 0 to 5. The distance from x to 0 is more than 5 units. So the top one means it's less than 5 units away. This one means it's more than 5 units away. So could the x be negative 4 anymore? No, because that's only 4 units away from 0. But could the x be, I don't know, like negative 6? Yeah, that'd be fine. So if we have negative 5 here, we're going to have an open circle going to the left, because it could be more negative than negative 5. That'd be more than 5 units away.
More negative than the negative 5?
Or it could be greater than 5. But could it be anywhere between these two numbers? No, then the distance will be less than 5. But we need the distance to be more than 5. Does this kind of look like your and or inequalities a little bit? Okay, it really does, doesn't it? And that's because our absolute value, like we talked about, creates two scenarios, the positive and negative. So we end up getting these where we're having kind of our 2 again, just like we had compound inequalities. Questions on that? Okay. One thing I want us to write on this top one is this is our x such that negative 5 is less than x, because negative 5 has to be less than whatever our x is. And x has to be less than positive 5.
That's not a good strategy.
You're right. So that's that is our and inequalities again, isn't it? That's our and compound inequalities again. And we notice it does end up going toward the middle like they did before.
I'm confused. I don't even know what we're doing. This is my braces.
Braces, are they pretty good?
They're really good.
All right.
This one
Okay. Now, on this next one, what do you think the second one is? Do you think it's and or? It's probably or, okay? X such that x is less than negative 5, or x is greater than 5. Because if we look at this...
Oh, my bad.
Oh, I got that behind there, didn't I? Can you guys see that, or do I need to redraw it out from behind there? Okay. I always forget about that finger thing because I don't see it on my screen. So this is saying that x has to be less than negative 5 or it has to be greater than 5. So if we look at how I got here, the x is greater than 5. Is that basically the same thing with the absolute value bars dropped?
Yeah.
X is greater than 5. Is that the same thing as what we see originally? Except for the absolute value bars are dropped? Yeah. But for the other one, we flipped the sign, didn't we? And we made it negative. Now, we've been used to, we did it on last section, so we're a little more used to making the second one negative. But here, not only did we make the 5 negative, we also flipped the sign. And if we look at the first one, x is less than 5, that's what we see right over here. But for our other one, we had to make it a negative 5, and we actually flipped the sign and made it x is greater than -5, which then can flip around to -5 is less than x. On to our last page of notes for this section, for this chapter even.
Wait, so we're almost done with notes, but we're not together for a long time.
Well, and it's not a super long time. It's really just a few classes. I'll talk about what we're doing with that. Okay? Okay? We might get to, okay? We're actually going to play it after our break. Okay, we're doing something else in the next class, okay? Probably not.
Lorax, it's about trees.
Yo, low-key, I was covering for Mrs. Shui's class yesterday, and we watched The Lorax. That movie bops, okay?
So good.
You must solve both cases with these. Hey, guys. Listen up, let's focus in here, okay? So, we are trying to solve these inequalities and graph these solutions. Notice they're absolute value inequalities. We have 2 steps, because we have to solve both cases. Here's our first case. Okay. We're going to rewrite the inequality without the absolute value bars. So our first scenario is just going to be x is greater than or equal to 4. Now what did we do for our second scenario last time on the equations?
Make it negative.
We make it negative, but now with inequalities, when we change up the signs like this, we have to flip the sign. So our other one is going to be x is less than or equal to -4.
These aren't ones, these are absolute.
Yep, these are absolute value bars. Well, that's a good thing to clarify. That's good. Okay? So, with our first inequality, we keep it normally. We just drop the absolute value bars and we say everything's the same. With our second one, we flip the sign and we make the right side negative. Before with the equations, we just made the right side negative. But can you really flip an equal sign? No, because it's just an equal sign. Okay, if you try and even flip it around, you still get an equal sign, okay? But you can flip these, and so we do flip them, okay? And so these would be our 2 inequalities. Now, are these 2 already solved? Yeah, it is, okay? Now, does this look, x is greater than -4, originally is how it starts. The absolute value of x is greater than -4. When we originally had the greater than, did that end up being our and or our or?
Yes.
Or, when we had the greater than originally, we had our or.
So,
So this is probably going to be an or here. And if you have trouble with which one it is, here's a hint. You could graph first and then go back and put in the or the and. So I'm going to graph a -4 and a 4. And what kind of circles am I going to have for both? Closed. Very good, Jack. You were ready for that question. Now, x is... Yes. X is less than or equal to -4. Which direction would my arrow go from -4?
I'm glad to finally meet you.
To the left. Very good. For x is greater than or equal to 4, where it'd go to the right. And so does this look more like an and or an or? It does look more like an or. So that's one way we can know it's an or. Our set notation x such that x is less than or equal to -4, or x is greater than or equal to +4.
On the test, do you find it wrong if we put x is greater than 4 or...
If you switch the order around, like if you put the bigger number first, I'll have to think about that. I've been pretty nice to you guys about that so far, but I keep telling you guys to try and not do that.
5 to 7 business days.
There's a good chance. Yeah. Let's go 5 to 7 school days. Okay.
Business days.
Sometimes. Oh.
Straight up, she answered my email once when I asked for help, and she said that I needed to set up a Zoom with her, and then would never set up a Zoom with me.
Oh, I would not. I don't like her and their mom called and they answered it. And she's like, get off your phone on my Zoom class. She like freaked.
Yeah, I never joined her Zoom class.
She showed her boyfriend and her boyfriend is
Her boyfriend was like a balding 22-year-old.
He's so he was like this and she was like.
All right. Number 2. The absolute value of r plus 3 is less than 6. We need to create 2 inequalities. Can somebody help me create the first one?
Yes.
I got it.
R plus 3
I'm kidding. I don't.
is less than 6.
Great. Can somebody help me create my second one? Courtney.
R minus 3.
Nope.
R plus -3. I don't know.
The left side stays the same.
R plus 3 is 3.
Oh, no. I got this. R plus 3 is less than, greater than, yep, that's right, -6.
Okay, the left side stays the same. What's in the absolute value bars stays the same in both. What changes is the sign flips, and the right side becomes negative. Now we solve these two inequalities. Now we've solved compound inequalities before, right? So this now just becomes a compound inequality problem. This is just like section 3.4 now. The first step is what's different is making the two inequalities. Every other step after this is the same. So what would I do in my left inequality, Elijah? R plus 3 is less than 6.
Subtract 3.
Very good. And so R is less than 3. What would I do in my right inequality here? R plus 3 is greater than negative 6 here. Josh, what would I do? R plus 3 is greater than negative 6. How do I get R by itself? Subtract 3.
Oh, yeah, don't listen to me. I was giving you wrong information.
R is greater than negative 9. Now both these R's are by themselves. So even before we jump into speculating whether or not we think this is and or, let's go ahead and try graphing it, and that'll tell us our answer, which one it is. So if I graph this, I'm going to have negative 9 on the left-hand side and 3 on the right. What kind of circles do I have? Open. Negative 9, what direction would that go if R is greater than negative 9? To the right? Okay, what direction would R is less than 3 go?
They meet in the middle.
To left. They meet in the middle.
It's an and.
It's an and. Now, we have to remember, we write our ands in a very weird way, don't we?
Yep.
So I'm going to put R such that, can anyone help me write this one? Okay, Alice.
R such that negative 9 is greater than R less than 3.
Okay, super close. You were right to flip around the negative 9 and the R, but then we had to switch it to negative 9 is less than R. So when we flip around, you said greater than, I believe. When we put the negative 9 first and the R second, we have to flip the sign. Okay? So negative 9 is less than R, which is true. Negative 9 is less than R because R is to the right of it. And R is less than 3 because it's to the left of it. Okay? Yes?
For like 2, when we subtracted the 3, are we supposed to flip the sign of that was
Great question. So when do we flip our sign with negatives? Is it adding and subtracting? Or is it something else? Multiplying and dividing by negatives when we flip it. Yep. Okay.
You have to divide by negative 1, and it makes it positive.
Okay.
Is that a 3 or a brace?
It's a brace. That's a 3 right there, but that's a brace.
No,
That's a brace at the end. That's a fair question. All right. Let's go on to number 3. The absolute value of 8 minus x is less than or equal to 3. How many equations am I going to have to write, or inequalities am I going to have to write? 2. Can someone help me with my first one? Okay, Courtney, go ahead.
8 minus x is less than or equal to 3.
Very good. Can somebody else help me with my second one? Jaden.
No.
Oh,
I didn't mean
okay. No. Oh, okay. Sorry, my bad. Okay. Courtney.
8 minus x is greater than or equal to negative 3.
Very good. The only thing that changed in the second one was the inequality sign flipped, and we made the right side negative. Just like with our equations, except for now we have to flip the sign. Now we solve these.
negative 5?
I'd subtract 8. Yep. And negative x is less than or equal to negative 5. But is this one all the way solved? No, we still have a negative x. How do we get rid of that negative x, Emily?
Divide it. Oh,
Okay, or Ellie.
that really sounds good. Divide it.
Divide by negative 1. Very good. Now, when I divide both sides by a negative, Abby Dash, what am I going to have to do? Flip it. So x is greater than or equal to positive 5.
Yeah, you go, x.
Now, in our right inequality, we're going to do all the same steps, but we're going to end up with a different number because it's compared to negative 3 instead of positive 3. Eli, what would my first step be here? Subtract 8. So I have negative x is greater than or equal to negative 11. What would my second step be here, Isaac? Divided by that negative 1. So x is now less than or equal to, we have to flip our sign, positive 11. So if x is greater than or equal to 5, and x is less than or equal to positive 11. And I still have to create my graph here. I'm going to do that in blue this time. 5 on the left, 11 on the right, because 5 is less than 11. What kind of circles am I doing here? Closed. What direction is my 5 going?
Right.
To the right. What direction is my 11 going? Left. What kind is this? And or? It's an and.
Oh wait, they meet in the middle?
They do meet in the middle.
Wait a minute.
If you didn't flip your signs when you divided by those negative ones, that would do it. Okay.
Oh, okay.
Wait, how'd you get 11?
When you divide by the.
Oh wait. Oh.
Okay.
My bad.
So x such that. Can anyone help me write this one? Alice, you want a shot at redemption with this one? I believe in you. X such that.
X such that. I haven't written it down yet.
Okay. Jaden?
X such that 5 is smaller than or equal to x is smaller than or equal to 11.
Okay. I never heard someone say smaller than, but it really is the same point, isn't it? Less than or smaller than. Okay. So x such that 5 is less than or equal to x, which is less than or equal to 11. Very good. And something Jaden did really well there was he flipped the 5 and the x around, and he also flipped the inequality. Okay? So he flipped the smaller one around, right at first, and then kind of smushed the second one into it. Because you only write the x once. Questions on number 3.
Come look at this graphic.
Is it a pretty good brace?
It's really
Okay. Gordon, you had one earlier that was pretty good, didn't you? Pretty good. Yeah. Whew, those are crisp. My goodness, I should have you guys teaching the class. Okay? What was your crisp one earlier?
Oh, I just have good ones. Hold on.
Oh, it's in general?
Do you want to see how
Sorry,
I
that's a
draw
weird
Yeah,
flex.
Like some of these, like, aren't they good?
I suppose. I've
It's
seen
a
worse.
super intriguing method of like this.
These are red. Right here. No. Look at these right here.
Did you guys see your face though when I said that?
These are mine.
She's like, how dare you?
Those are good.
Those are okay.
They're good.
It's too easy. All right, number 4. I want you guys to try number 4 here.
No one draws better braces.
We're going to have a brace competition here, okay? So try number 4. When you have it or have questions on number 4, raise your hand. Oh, okay.
I agree with that statement 100.
So x plus 4 is greater than 2. Can someone help me with my first inequality?
No.
Elijah, thank you. Help me with my first inequality, Elijah.
Right now, as x plus 4 greater than 2.
Very good. Can someone help me with my second inequality? Okay, Haven.
X plus 4 is less than.
Exactly right. Second one, we keep the left the same, flip the sign, right's negative. Now we solve these. To solve both these, we subtract by 4. Okay? Brady, this is what you have, remember? We talked about that.
No, I had x plus 4 greater than -2.
Yeah, and we talked about that's the one thing you'd have to change on that. So that's what you asked me about, and I said yeah.
I was talking about the one that I had, the x.
This one?
No, not that one.
Yeah, the other one.
Yeah.
Yeah, so this sign, we said you needed to flip it. The first one, we subtract 4, x is greater than -2. Second one, we subtract 4, x is less than -6. We graph these. -6 on the left-hand side, -2 is on the right, because -6 is less than -x. They're both open circles. Which way would my -6 go?
Mullets are so ugly.
To the left, and -2 would go to the right. So which one is this, or and? Or. So for my set notation, I'm going to put my set notation up here, guys, just because I have room. X such that x is less than -6, or x is greater than -2.
There's so much work for such like a little problem.
It does feel that way, right? Because it's kind of like we're doing double the work because we're doing 2 inequalities.
Where do you get the 7 from?
I don't know what you're talking about. We don't have a 7
Oh, I thought that was 7 minus 2.
at the end.
Yeah.
It's a -2. I think it just wrote. It's kind of wrote weird, but that's a 7. That's a 2. Excuse me.
I need help because I don't understand.
Oh.
Because why are they going that way?
Okay. So is this? Did you get x is greater than -2?
Yeah.
Okay. So if x is greater than -2, what numbers are greater than -2? Well, -1, 0, 1, 2.
Why is it that way?
With the other one.
Just you.
Okay. So did you have x is less than negative 6?
I had x is greater than.
Okay. So when you wrote the inequality, did you have x plus 4 is less than negative 2, or did you have x plus 4 is greater than negative 2?
Greater. So
When you make the negative one, so when you make your second inequality, not only do you make the right side negative, you also flip the sign. Okay.
so
Would that clarify that for you?
So wait, then they would.
We have to take those up for you.
Wait, so 2 would be going this way. So wait, so. Okay.
Okay. Cool. Jaden.
When would we use this in real life?
Yeah, great question. When will we use this in real life was our question that was just asked. Okay. So there's kind of twofold answers. Okay. The first answer is kind of a more generic one, to be honest, but it still is a legitimate answer, just so you guys know. So the first right there, the poster. Okay. The first answer is school is made to be of an overall very generic thing for you guys because. Do I know, or does everyone know where every single person is going to go after high school? No, there's a lot of different options, isn't there? Okay, you don't even know where you're going after high school. You might know, some of you might not, and even if those of you that think you know, you might change it. It's possible. Okay, maybe you won't, maybe you do. So there's a lot of different places you could go. So you could end up doing a lot of different things. So what school is designed to do is it's designed to kind of prepare you for a wide array of things. So ideally, I'll get there in a moment. So ideally, you would end up being prepared to go further down any sort of path. Okay, that's kind of the ideal scenario, is what's happening. Okay, so that's the goal there. And so you might not end up using this personally, because you might not end up pursuing a career or any sort of thing where you end up using this exactly. And so you might use something else we teach in math. So we teach both because someone else might use it, but you might not, but you don't know yet. Does that part make sense? Okay, so you don't know what you're going to need and what you're not going to need yet. So we're going to teach you a general array of things, and this could be it. And you might need something later on, but your neighbor might need this, and they might not need that late thing later on. Now, where could this specifically be used? Okay, so this specifically could be used in maybe a lot of computer programming. Okay, so a lot of this stuff could be in computer programming, for example. Okay, it could also be in some different business things. Okay. It could also be in different scientific calculations. Okay, so it could be a lot of computer science or some business as well. Okay, so those are some more specific careers that could use it. But the answer is, why are we all learning it? I don't want to do that. Well, the thing is we don't have the ability to do individual programs for every single person, and also we don't entirely know where every single person is going to go.
We should do a survey on that.
So the academies is to help with that. Actually, that's part of the reason the academies is to help with that. And so you're getting a little bit more of what you have as your career interest right now in that than you would in a normal school.
Or not everybody in the classroom in the same academy.
And that is part of the downside to it. So ideally, you're getting more of that in your advisory a little bit.
What's your academy?
Okay. Any other questions on that before we move on to the next problem? Okay. Number 5 and number 6. These are the last two problems of this entire chapter. What if the absolute value expression is compared to a negative number? Okay. So the absolute value of x plus 2 is less than negative 1. So before, when it was equal to a negative number, we just automatically said that couldn't be true, right? We said there was no solution when it's equal to a negative number. Now we don't have it equal. We have it as an inequality. So let's think about this. Out of our absolute value thing here, what's the lowest possible number we could get out of that? What's the lowest possible number you can get out of any absolute value ever? 0 is the lowest you can get, right? So it's either going to be 0 or bigger, right? So we know this is going to end up being 0 or a positive, right? We know that, don't we? Out of our absolute value, once you take absolute value of something, you're either going to get 0 or some positive number. So would 0 or a positive number be less than negative 1? No. So does this one have a solution? No. So this one's no solution. So we think, well, what's the lowest possible number we could get? 0. Well, is 0 less than negative 1? No. But on the second one, the absolute value of 2x plus 7 is greater than or equal to negative 11. Once again, what's the lowest possible value you could get out of an absolute value? 0. So So you're going to get 0 or a positive number again.
No solution.
Now, is 0 or any positive number greater than or equal to negative 11?
Yes.
Yeah. So that's IMS. Because no matter what you get out of there, it's going to be greater than negative 11. But on this left one, whatever you get out of there, it's not going to be less than negative 1. It's always going to be bigger. Go ahead.
Is it like that, then it's only, like, you're only one of those two?
So if you, once again, have only absolute value is less or equal to, less than or greater than, a negative, it's going to be like that. Now, if you have other stuff on that same side of the inequality like we did earlier, like I went through the question on our homework, then that'd be a different scenario, potentially. But here, only absolute value is less or greater than a negative. It's going to be one of these two. And you're going to say, once again, what's the smallest that we could possibly get? 0. Well, is 0 less or greater than that number? And that's our whether or not it's true. Does that make more sense or no?
Can we throw away this homework?
Okay. Here's what I suggest doing with that homework, okay, is I would suggest holding on to it until you're done with the review, okay? But you guys are able to throw it away if you would like. You have the choice. I would suggest holding on to them. Chapter 1, as long as the grade's accurate in Infinite Campus, you're fine to throw that away. I would suggest keeping reviews and notes, though. So I would suggest keeping reviews and notes because our final is comprehensive over the semester. Okay, so the reviews and the notes can help you out to study for the final. No, Jaden.
We got homework.
Yes, we do. I'll get to that in 1 second. We only have 6 problems. Yes. Yes, I'll get to that next. Okay. Okay. So first thing, test. Okay. Test. When is our test? Okay. Our test is going to be.
Wednesday.
Let's walk through when we have classes. Okay. So we have class today on Fun Talk Friday. Next week we only have school Monday, Tuesday, Wednesday. So we'll only have class on Tuesday. Okay? We'll only have class on Tuesday next week. Okay? So on Tuesday, we're going to do an activity. Okay? It'll be a surprise. Okay? Then the week after that, we'll have class Monday, Wednesday, Friday. Monday we will review. I don't want to have you guys review and then have 6 days before you take the test. That's a long time. That's really hard on you guys. Okay? So we're going to do an activity on Tuesday next week. Then the following Monday after our break, we're going to have a review day. Then on Wednesday, we'll have our test. So it's actually 2 weeks from 2 days ago. So it's 12 days from now. 12 days from now, we will have our test. Does that make sense? It'll be the 28th of October, okay? Which is 12 days from now. Questions on that? Okay. We can while we do this homework. Yep. And I do have some only do's. Okay. So instead of some don't do's, I have some only do's. Okay. I'm going to say like only do these.
I like this color of the paper.
Good. It's a nice golden rod.
It reminds me of Spanish. It's Aura. Aura. Aura.
I'll say aura is hour. So I'm not sure what you're saying.
Let me guess, we're doing 1, 2, 3, 4, 5, and 6.
Aura. Aura. There's no H in Spanish. Aura and hour. Russian, English, we don't pronounce Arabic. It only speaks like 7 words. I don't. 8 O. Except for. I didn't say X pronounced. I don't know.
Okay, you guys ready for this? It's going to appear in the middle here in blue. Only do. So these are the only problems you're supposed to do. Numbers 1, 5, 7 through 9, and 15. 1, 5, 7 through 9, so 7, 8, and 9, as well as 15. I only want you to do 6 of these problems.
Oh, of course, 15 is the 2-part.
Are they the hardest ones on
Really get me like that, huh?
I mean, yeah, but no. I mean, it is, but like, it also isn't.
What did I get on my quiz?
Okay, I'll show you those in a moment. Any questions?
Do we have to do it like the way
I
that we
had
did it before?
I took pills in your
Yes.
but it's not helping.
Yep, so I want set notation, I want graphing, I want all of that.